Hello everybody. By this video I want to introduce you Visc, the virtual intelligent soccer coach application, useful to provide live advice to the coach during a match through a mobile straightforward dashboard.
Well, Visc is a smart application that gives the coach real-time indicators on the actual team performance during a match. Visc can help coach to take decisions based on objective data. The indicators are computed by using the sequence of the pitch tracks, later on referred as trajectories of all the players and the ball in a given time frame. They are stored into a kinematic matrix. The key indicators are displayed as a variable colored dashboard for a quick look. The dashboard output is made simple, clear, straightforward, meaningful, easy to read. The calculated tactic indicators are logistic efficiency, pitch coverage, team average density, and play flexibility. And now we are going to introduce each of them.
The logistics efficiency indicator measures the ratio between the sum of the trajectory of all the players of the team and the sum of the trajectory of the ball when maintained by that team. Logistic efficiency can be calculated at different sub-team levels. The value can be compared with the seasonal average to point out the difference and give to the coach a quick feedback on current team performance. A bar histogram image represents the result, and possible alerts highlighted in red. Logistic efficiency indicates to what extent a team is well organized to carry the ball to the opposite goal, minimizing the waste of physical limited resources. The pitch coverage indicator measures how many times a portion of the soccer field has been crossed by a player or a team. It can be calculated at different sub-team levels. A pictorial map is produced to show colored pitch areas with poor coverage, that means below a given threshold. Field coverage provides a snapshot of the pathologist area and therefore suggests to the coach how to better distribute the team members on the pitch during the match. The average density indicator measures the sum of all instantaneous distance between team players and then added up in a given time interval to calculate the average. The average sub-team density can be calculated at full field level or at single sub-team level during the phase, attack defense. The data can be compared with the historical average figures recorded in kinematic base. The average density parameter gives the trainer an objective information on how dense the team plays, that is, at what extent the players do cooperate during the game to keep a mutual distance as stable as possible. The flexibility skill indicator measures the average number of save passes a team potentially had during the game. The flexibility can be calculated at full field level, field zone, and time intervals. The value is compared with the average figure stored in the historical time series. The flexibility of the game gives a picture about the team's ability to create more opportunities to continue to possess the ball through secure passes while approaching the opponent goal. Flexibility is the skill that focuses on the team player's ability to adapt to new situations, improvise and shift strategy to meet the different types of challenges during the game.
In the following slides, I will show you the different appearance of the different indicators. In this one, you can see the logistic efficiency for each player of the team, and we can also have a total value for the overall team compared with the average value. What is important is that we can supply information to the coach about alerting that some player is well below its normal standard. This is the dashboard showing a pitch coverage with the red zone where the number of team players passes was before 5 in the given time frame of 45 minutes.
In this slide, we show the team attack density calculated during a time frame of 25 minutes, and this value is compared with the average, so the coach can have a feedback of how the sub-team is working. Once again, in this slide, you can see the value of the flexibility skill during 45 minutes of playing. This slide shows up the different record configurations with 1, 2, and 4 video cameras, depending on local conditions. In any case, concurrent shots are merged together to create one single track. This slide discloses how the trajectory is produced. In A, we have shots at 25 Hz frequency. In B, the processing frame has selected 1 per second at a frequency of 1 Hz, and the player is identified. In C, the player is recognized and labeled. In D, the simplified 3D back projected track is built up 1 segment at second for all the players captured in the video. The kinematic matrix is a compact digital bidimensional array storing the encoded relative positions of all the players and the ball at every single second of the match, where the sign plus means possessing the ball, the sign minus without the ball, and the 0 means no data is available. You can also use it to replay a match on a game or workstation for further training. This is an example of how 3 trajectories coordinates during a time interval are encoded in the kinematic matrix. In this one, you can easily detect events such as ball possession or kicks. This is a typical dashboard layout where all the different indicators are show up together: logistic efficiency, pitch coverage, team defensive density, and flexibility skill. This is the innovative core of the Visc application, the Smart Advisor. Using a technique of artificial intelligence, we developed a neural network module that can learn from best example how to optimize the performance of a match, given the level of the opponent, the ability of the players, and the adopted module of play. The smart advisor suggests optimal change to the coach by moving the position of the player on the pitch or substituting some of them with new ones, reducing the cross entropy of performance. The neural network module is training by using data from previous match that the coach considers good performance samples. We must to underline that the adopted learning algorithm is the well-known negative gradient method, which links the output to the change of the weight of the neural network. And we also want to tell that the enabling technology that we have used is TensorFlow. Now you see how Smart Advisor works. First, the dynamic indicators of attack sub-team are calculated either from gold reference match and from the current match trajectories. Then the TensorFlow app is applied and the resulting change to minimize the cross entropy underlined in red. Finally, Visc gives its advice to the coach using such result from the TensorFlow app. Before to conclude this presentation, I wanted to tell you about additional feature of the Visc app. The first is that fast-tracking the object of interest is implemented through an intelligent visual recognition tool, exploiting 3 concurrent algorithms. This guarantees for accuracy of the result. Second, the 2D, 3D back projection is computed using the offline data describing the geometry of each background play field of the segmentation of the foreground object. Third, if the reconstructed trajectory covers subset of the elapsed play time, a confident index is associated to the figures. Display has variable call intensity on the dashboard. For the kinematic matrix image can be used for further post-processing purposes, example given training, bit data analysis, and so on. 5, the dashboard is up to date every time second. Well, now I'm going to finish this presentation just telling you that we are looking for pilot tests to improve player labeling accuracy, to estimate the retromapping 2D, 3D bias, to optimize video camera positioning and compare trajectory precision when using 1, 2, or 4 camcorders, to benchmarking Visc against incumbent solution, to tuning the Smart Advisor tool upon coach policy and optimize the dashboard system for the training by exploiting a user experience. The test point will be developed in a series of 30-minute tries each. Thank you for your attention.